12 learners. Welcome to today's technical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we'll be focusing on paper 2, hoping that you have enjoyed your paper 1 today. We are saying on come Tuesday, you must be ready. You have the whole weekend to revise. So as we start now, we are saying, let's look at the weighting. Remember paper 2, we have 75 marks. So you'll be writing for 1.5 hours. And then those are the weightings of the cognitive levels. You can see that you have many percentages in recall questions, level 1 questions, and level 2 questions there with 35%, and level 3, that includes calculations and applications there with about 30%, and level 4 which is only 5%. Now we are saying you will be ready for that paper, and we will ensure that this lesson makes a difference in terms of that. So we deal here with 2 modules in terms of paper 2 of technical science. We have organic molecules, we have electrochemistry, and alternate energies. So that will be our focus. Remember, you have semiconductors as well as part of metal materials. We'll touch that as well, so that if there are questions that talks to that, you are able to respond to that question. So this is the focus for the day. Now, we will go straight. We have taken a question paper so that we are able to utilize it for our revision, so that you can be able to see how the paper looks like and have the feel of what you are expecting come Tuesday, so that you are able to answer the questions. So the questions that I've taken questions from your June paper, the supplementary paper that was written May, June this year. So I hope it will be able to help and guide you as to what to expect come Tuesday as you write your paper 2. Now, if we look here, and we have question 1.1, which is a multiple choice questions. We are saying that to answer multiple choice questions, what do you need? We are saying the first thing, which is the most important thing, you must be able to read. So as you will be doing multiple choice questions, please ensure that you are reading, and time yourself so that you don't spend much more time on one question. Remember, each multiple choice question has 2 marks. So we're expecting you to spend at least 2 minutes there in each and every question. So I will try to do that so that I'm able to model, so that you are able to see how to go about doing this. So what you will do, you will read the question. We say which one. You can see 1 is written in capital letters. It shows that it's a keyword. You are not choosing 2, you are choosing 1. Which one of the following homologous series has a carbonyl? So carbonyl group is in caps lock there. It shows you that this is your focus now. That's what you're going to be focusing on. You are looking for a carbonyl group as a functional group. You go to number A, you look at number A, you'll say these are haloalkanes. A says haloalkanes. You can say halo, these are group 17 elements in the periodic table, of which in technical science we only do bromo and chloro. So we have only 2 of them, bromo and chloro, and they are attached to an alkane. Hence we are saying say haloalkane. So you can be able to see that in terms of there is no carbonyl in a haloalkane, because haloalkanes have bromo or chloro or have group 17 elements. Now aldehydes. Now we will look at aldehydes, because a carbonyl is a C double bond O. So it's very much important that you look at that, because aldehydes does have a C double bond O. Let's look at alcohols. Alcohols, they have an OH or a hydroxyl group. So you will see that alcohols and haloalkanes are distractors. So you remove the distractors, which is your haloalkane, which is wrong because it has bromo and chloro with the attached to an alkane structure. Now we have the OH that is going with the alkane structure there, which is your alcohol as well. This one will be out. There is no carbonyl there. But now you are left with option B or D, which means one of the 2 is a possible answer. Now if we look for aldehydes, you'll say C double bond O. At the end there you need an H. So for ketones, you will say C double bond O, and that C double bond O must be surrounded by 2 carbons. There must be 2 carbons between the C double bond O. And these ones where you have a C double bond O attached to a hydrogen of aldehydes, we call it formyl group or formyl group. So it's a formyl group. The functional group is a formyl group for aldehydes. So you are able to say B is not the answer because it's a formyl group. The one that is a carbonyl group is this option number D, which is a ketone. So you choose D, you are sure, you got your 2 marks, you are able to move to the next question. Now let's move to 1.2. And then 1.2 was consider the structural formula of the alcohols given below. So they are telling you in the statement that these are all alcohols. So you just have to look, alcohols, we are saying they have a functional group, which is the hydroxyl group. Hydroxyl group is the OH there. I think you can see already that these are structural formulas, because structural formulas, they show all the bonds. So you're able to see all the bonds that we are having there. Hence, we refer to it as a structural formula. If it was not a structural formula, maybe a molecular formula or what, we won't show the bonds. But when you show all the bonds, that is a structural formula. So they are saying all of them are alcohols. We agree with them to say indeed they are all alcohol. They have a hydroxyl group. Now, primary alcohol. So this, as we are revising in preparation, you are able to ask yourself, what is a primary alcohol? Remember, we're saying a primary alcohol is the one where the carbon that is bonded to the hydroxyl group, the carbon that is bonded to the hydroxyl group is bonded to one other carbon. So that's what we are saying. To say, that's how you will define a primary alcohol. You will say a carbon that is bonded to the functional group, or the carbon that is bonded to the hydroxyl group is bonded to one other carbon. So there is no any other carbon. Which one is that? Let's look at this carbon. This carbon is bonded to 2 other carbons, so it's not a primary, because the carbon that is bonded to the OH must be bonded to only one other carbon, not 2. When it's bonded to 2, we call it secondary. So this number, Roman figure 1, is our secondary alcohol. I hope you understand why we're saying it's secondary. We're saying we always look at the carbon that is bonded to the hydroxyl group. If the carbon that is bonded to the hydroxyl group is bonded to 2 other carbons, we refer to it as a secondary alcohol. Roman figure 2, if you look at it, the carbon that is bonded to the hydroxyl group is bonded to one other carbon, so it qualifies to be a primary alcohol. Let's go to Roman figure 3. You can see the carbon now that is bonded to the hydroxyl group is bonded to only hydrogens. It's not bonded to any other, because remember, for methanol you are having only one carbon. So there is no way that that carbon can be bonded to another carbon for methanol, because for methanol we are saying we only have one carbon. So that is an example of a primary alcohol. So we have primary alcohol in Roman figure 2 and Roman figure 3. But now let's go to the Roman figure 4. Let's look at Roman figure 4. We're saying now the carbon that is bonded to the hydroxyl group is bonded to 3 other carbons. Now there are 3 around this carbon. So the carbon that is bonded to the hydroxyl group is bonded to 3 other carbons. So that will be tertiary. So we are saying this is a tertiary alcohol. That's why we're revising all of them, because we don't know, the examiner on Monday or Tuesday will be asking which one of them, if they will be part of the paper. So it's important that you know all the primary, secondary, and tertiary alcohol. I hope I was able to explain to you. And we are saying the primaries, the ones that are qualifying, is Roman figure 2 and Roman figure 3, which in this case is option number C. So you are able to choose option C there. You get your 2 marks, and then you are smiling, you are moving. So you are able to get your 2 marks. I hope you are following and we are moving together. So you can see that the first 3 questions that we have been doing, including this one, it is still organic molecules questions. A liquid with high viscosity will flow. So you are looking at the keyword there is that high viscosity. So you have to first remember the issue of physical properties. Remember, in technical science we do 4 physical properties, which is your melting point, your boiling point, your vapor pressure, and your viscosity. And we are saying out of these four, all of them, you see, as the strength of intermolecular force increase, the melting point increase. So all these, they increase with the strength of intermolecular force. Your melting point, your boiling point, it increases with the increase in the strength of intermolecular force. Viscosity does the same. It increases as the strength of intermolecular force increase. However, vapor pressure decreases as the strength of the intermolecular force increase. So that is the only one which decreases when the strength increases. So you are able to see that, okay, viscosity, it means as the strength, if you say high viscosity, you are saying it has a high strength of intermolecular force, which will mean that now, will it flow fast or slow? Let's look at it. The first option was it will flow faster because it has a high boiling point. Yes, it will have a high boiling point, but it won't be faster because it's more viscous. The intermolecular force are more strong. The structure is holding each other together by strong intermolecular forces. So faster, we take it out to say it can't be faster when it's high. It has high viscosity. So we're looking at our option which is slow. It must be slow. So why is it slow? Is it because it has a low boiling point? No. If it has a strong intermolecular force, it means that it must have a high boiling point. So you're able to see that option number C as well is a disruptor. So our good option is option number D, which will say it will flow slowly because it has strong intermolecular force. So you're able to get another 2 marks. I hope you got that and you have understood the four physical properties that we do in technical science grade 12. Now let's move to question 1.4. You can see that question 1.4 now is based on redox reactions. Remember, redox reactions is question 5 and question 6. Remember, in question 5, we're expecting electrolytic cells, and question 6, we're expecting galvanic cell. Now, that is the structure of our national papers in terms of technical sciences. Now, when we say it's redox reactions, we're saying these are reduction oxidation reaction. So when one substance will undergo oxidation, another one will undergo reduction, and we refer to that as redox reactions. Now, they are saying an oxidizing agent. Remember, if you are an agent, if you are an agent, it means, let's say you are a sales agent, you are selling something. You're not selling to yourself, you are selling to other. If I'm an oxidizing agent, it means I'm an agent that is going to oxidize. So it's very much important to understand that we move in that order. So you'll have to get it to say we are having oxidizing agent. We're saying the first option is saying is oxidized. It cannot be oxidized when it is an oxidizing agent, because what it's doing is oxidizing. It's an agent to oxidize. Itself must be reduced. So we must be able to get it that we must be able to reduce it. So we are moving to 1.5, and then we'll come back and finish 1.5. Let's go for a 5 minutes break, and then as we're coming back. Thank you very much. we are busy with question 1.5, which is our last question. Remember, we have 10 marks from multiple choice questions in terms of paper 2. So now the question is saying, which one of the following is applicable to both an electrolytic and galvanic cell? So the keyword, you see, when we're doing multiple choice, the keywords are most of the time, not always, most of the time we try to make them in capital letters so that you are able to know that this is what we are looking for. So we are saying which one is applicable to both electrolytic and galvanic cell. Let's look at option number A. It says anode is positive. You know that in electrolytic cell, anode is positive. In galvanic cell, anode is negative. So it doesn't apply to both of them. So number A is not a correct answer. Cathode is negative. The same applies. Cathode it can be negative in terms of electrolytic cell, but cathode is positive for galvanic cell. So it doesn't apply that statement. We are only left with two options, which is C or D. It says number C, electron flow is from cathode to anode. You will know that electron flow is always from a negative electron, which is our anode, to cathode. So electrons will always, whether it's galvanic or electrolytic cell, electron flow will always be from anode to cathode. So don't forget that as you prepare yourself to say electrons, they always flow from anode to cathode. Now let's move to now preparations for question 2. Remember, for question 2 you are doing naming of organic molecules, including isomers there. So now it's very much important that you start and you understand the definitions. Now I will just take you through this slide so that you are able to understand, and then we'll rush and go and do the questions, because we want to spend much time doing questions. Now you have to know what are hydrocarbons. We're saying hydrocarbons are organic molecules that are made up of carbon and hydrogen atoms only. So the keyword there is made up of only carbon atoms and hydrogen atoms. So there is no any other atom, it's only carbon and hydrogen. So you have to know, for example, we have shown there that some of them can be saturated, and for saturated we're saying these are alkanes. Alkanes are saturated. What are saturated hydrocarbons? We're saying they contain only single covalent bonds. So saturated is for single covalent bonds between carbon atoms, and the unsaturated, they contain double or triple bonds, covalent bonds between the carbon atoms. So it's very much to understand, for you to understand that when they are like this, we say they are saturated. Why? Look, focus on the S there to say saturated. They have single covalent bond between carbon atoms. As you can see, this all of this structure doesn't have any double or triple bonds between carbon atoms. Now let's look at alkenes, for example. We say they are unsaturated because they have a double bond between carbon atoms. The alkynes, they are unsaturated because they have a triple bond between carbon atoms. So I think you are following that. And the other thing which is very much important as we start with this question 2 now, to say the order that you put you structure your revision, you must first be able to look at what we refer to as general formula. For alkanes, for example, we're saying alkanes, they have general formula CnH2n plus 2. That is the general formula for alkanes. Now what you have to do is that you have to know that the N stands for the number of carbons. So if we have one carbon, we'll say C1, 2 times 1 is 2 plus 2 is 4, so you'll have CH4. You see, so you must be able to know that the number of carbons, N stands for the number of carbons. So we are able to move from general formula to molecular formula. And you must be able to move from molecular formula to structural formula. Remember, structural formula, we are saying you show all the bonds. You show all the bonds that are involved there. So when I write CH4 structural formula, I will write it like that. So you have to know these different ways of writing our structures. For example, in this case, what we have here, we have CnH2n plus 2, but now we have 3 carbons. So this is now C3H8. So you're able to see that is the molecular formula will be C3H8, and then the structural formula you will be able to draw like that. And we have another formula which is the condensed formula, that some of the time you will find that we do include condensed formula. So it's important that you you understand condensed formula. For example, if you have propane like that, if I'm to write a condensed formula of that, I will say CH3 because the first carbon has 3 hydrogens. I will say CH2 and CH3. So this will refer to it as a condensed structural formula. So it's very much important as you go to exams to know which formula, because when you ask you a question, it will say write down molecular formula. You got to know that the molecular formula will just show us how many carbons do we have, how many hydrogens do we have. That is the molecular formula. If we say draw structural formula, we're saying show all the bonds. So you will still write CH4, but you will be showing all the bonds. If we say write down condensed structural formula, you will be able to get a structure that is condensed in that form. So please always remember the types of these formulas that we are using. We are focusing on the 4 formulas, which is we're saying is the general formula, is the molecular formula, is the structural formula, and the condensed structural formula. So you must know all those 4. And I'm saying, I want to emphasize as well to say, as we move from alkanes to alkenes, we remove 2 hydrogens so that we can have a double bond. That's why we have the general formula of alkenes as CnH2n. As we move to alkynes as well, we remove another 2 hydrogens. Hence, the general formula becomes CnH2n minus 2. So I want you to understand that for hydrocarbons, the general formula for alkanes is CnH2n plus 2. But when we move from alkanes to alkenes, we remove 2 hydrogens. The general formula will become CnH2n. When you move to an alkyne, the general formula will become CnH2n minus 2. So please, at all time, remember the difference there. Now, all these we refer to them as homologous series. Homologous series. In technical science, we are doing 9 homologous series, which in this case, our homologous series is our AAA. I like to put it that way. AAA, Hague. Don't forget, all the questions that we are going to ask you on this section on organic chemistry will be based on these 9 homologous series. What are they? It's alkanes, alkenes, and alkynes. And I just said to you, all these are called hydrocarbons. Why are they called hydrocarbons? They are made up of hydrogens and carbons only. So there is no any other atom. It's only carbon atoms and hydrogen atoms. So we refer to them as hydrocarbons. And there are 3 hydrocarbons that we're talking about. Is your alkanes, alkenes, and alkynes. And I showed you how the general formula changes from alkanes to alkenes to alkynes. Now we have Hague, which is your haloalkane, your aldehyde, your ketones and esters, your alcohol and carboxylic acid. So you must know that we have those 9 homologous series. Now the question is, what are homologous series? So we're saying homologous series are a series of organic compounds that can be described by the same general formula. It means all alkanes, they have the same general formula. And then as we take the definition further, we'll say each member differs from next by CH2 group. For example, if you move from propane to butane, as I've given you in this example, you will see that the difference is a CH2. If I remove this CH2 here, butane will be the same as propane. So it's important for you to understand to say homologous series, they differ. One member differs from the next by CH2 group. So that's how you will define homologous series. They are described by the same general formula, and each member differs from the next by the CH2 group. I hope you got that, and it will help you as you go forward. Now, we're saying these hydrocarbons, they can be unbranched. As you can see here, we're having an alkane that is unbranched, we're having an alkene that is unbranched, we're having an alkyne that is unbranched. But as well, they can have branches. They can have branches. You can see it has a branch now, it has a branch, it has a branch. So these are different structures. We can have branch and unbranched structures. So you must be able to differentiate between a branch and unbranched. Most of the time, when we're doing chain isomers, we're going to refer to the branches and the unbranching there in terms of you understanding the questions. Now, going straight, because we don't want to waste time, we want to give you skills to say, how do you name an organic molecule? What is the best strategy or simplest way that you can go and name your organic molecule? So if you check here, when I started, I said AAA, Hague, ANC, and then that is to say AAA is alkanes, alkenes, and alkynes. And the Hague, I said, is for haloalkanes. So when you name your alkanes and alkynes, and your haloalkanes, what you will do, this is what I'm referring to now. When you name those first four, what you will do, you will look at the number of carbons. The number of carbons will tell you that if you have 1 carbon, it's meth. If you have 2 carbon, it's eth. If you have 3 carbon, it's prop. If you have 4 carbons, it's but. If you have 5 carbons, it's pent. If you have 6 carbons, it's hex. Now, this applies to these 4. However, for aldehyde, ketones, esters, alcohols, and carboxylic acid, your stem now becomes methane. You'll say methane. If you have 1 carbon, you say methane. Why do we say methane? We don't say meth. Look at it this way. Let's say we are having a methane for an alkane, a suffix, because the suffix is from the homologous series. So we'll look at the functional group. So let's say it's a meth, which means 1 carbon, and because there are no double bonds between carbon atoms, so it's a methane. So we'll add an ane. So it's a methane. So you say methane. This is the suffix. The name must end with the ane. This is the prefix of that particular name. Now look at ethane, for example. You'll say ethane. So you are able to add that into that. But now, if we are dealing with the same applies when we're dealing with alkenes. You can say ethene. You just add the in there. Propene. The same when you're dealing with the alkynes. You'll say butane, pentane, and hexane. But you will tell us the position where we find the double bond or the triple bond. It's very much important that you don't just write it say pentine. You tell us where the double bond is. If the double bond is in carbon number 1, you'll say pent 1 wine, and then hex 1 wine or hex 2 wine, in that way that you do it. Now we are going to do naming. We're saying when you name the name, if we have a bromo, chloro, methyl, or ethyl as a substituent, if we're having a substituent or a branch, the name must always start with the branch. So the first thing we'll start with, we're going to look for the prefix, which is the branch. Do we have a branch? If we have a branch, we must write down the branches. And then the second thing that we're going to look at is the longest carbon chain. How many carbons do we have in the longest carbon chain? In the longest chain that we're having, how many carbons do we have? If we have 1, and we'll say meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex. You'll understand as we do it practically. And we are saying these prefixes, if you have 2 bromos, you don't say 2 bromo, you'll say di. So when it's 1, you'll say bromo. When it's 2, you'll say dibromo. And you must indicate their position on the structure. It's good when we talk about this and you are doing an activity. Hence I'm rushing to this one so that we can be able to do the activity. Now I want you to understand and go and collect these marks. Now as you get a question, you'll find that most of the time, we're not saying all the time, but most of the time we're giving, if you look at our papers from 2018 when the subject starts, you'll see that question 2, we are having a table where we have different organic molecules there, and then we then ask you questions based on that table. Now if we look at this table, for example, you will come to number A. You must be able to check what is the functional group there, and the functional group there, you will be able to see that it's a carbon-carbon double bond. So you will know that these are homologous series is alkene. Why? Because the functional group is carbon-carbon double bonds. So you are able to see that, okay, this is an alkene, and then you know the general formula for alkenes is CnH2n plus CnH2n. Remember alkenes, it means we have removed 2 hydrogens, so it's CnH2n. So those things are very much important. Hence I've written here F, which is the functional group. What is a functional group? Is that which makes this structure different from alkenes. What makes this structure different from alkenes is the carbon-carbon double bond. That is your functional group. And we are saying that the homologous series for where we have a carbon-carbon double bond is alkenes. What is the general formula for alkenes? CnH2n. That's what we have written there. What is the molecular formula? Molecular formula, we're simply saying how many carbons, how many hydrogen, how many atoms do we have. So molecular formula for this one will be C2 because we have 2 carbons, H4 because we have 4 hydrogens. I hope you got that clearly, and we don't have a problem. So we'll have a C2H4. Now, when you continue, you will be able to say draw structural formula. This is the structural formula. Condensed, I told you already that condensed, you are saying on this carbon, how many hydrogens do we have? So your condensed, you'll say CH2, CH2. So that is your condensed structural formula. And then we can be able to check whether they are isomers. You are saying no, there is no isomer of this one. But now, the name, the N there stands for the name. What is the name of the structure? So you must be able to know what is the name. I said to you, you will look at the number of carbons. We said 1 carbon is meth, 2 carbon is eth. So this one is 2 carbons. So you'll see this is eth. But now, because it's an alkene, the suffix, the name must end with in, because it's an alkene. So you will say this is an ethene. So as we are focusing mostly on the naming, we'll go to the structure and be able to say, now, what is the name of this one? I think we came across something like this, where we had an aldehyde. We said an aldehyde, it has a C double bond, O and an H at the end, which you said is the formyl group. So you must be able to name this structure and say, okay, for alkenes and alkynes, including the haloalkanes, we said you use what we refer to as meth for 1 carbon, eth for 2 carbons, prop for 3 carbons. But for other homologous series, like this one is an aldehyde, you won't say meth. You won't say, because it's 3 carbons, you won't say prop. You will say propan. So I want you to understand that. We say propan, then we just look at the homologous series. It's okay, this is an aldehyde, so the name must end with al. So this will be propanal. So you must be able to do that and be able to get the correct structure. So okay, we have propanal there. Here we have C3H4. If you are given a molecular formula, it's very much important that you first draw it, structural formula, so that you can see the type of structure that we have. We have 3 carbons, 1, 2, 3, and we have only 4 hydrogens. So I can put a double bond there and a double bond there. How many 4 bonds on that one? 1, 2, 3, 4. Let me check that. It's a C3H4. That structure was, because you don't do dienes in terms of your structures in technical science. So you had 4 hydrogens and C3H4, which was I think a problem for you as C3H4 there, because it will mean that you have 2 double bonds and you only do 1 double bond. Let's go to number D, where we have pentane. Pentane now we are saying is 5 carbons. So you will have 1, 2, 3, 4, 5 carbons. Then you must be able to draw all the hydrogens. Remember, each carbon must have 4 bonds around it. So always count the number of bonds around each carbon, because if you have drawn a structural formula, you must always check that. So that will be the structure of pentane. Now as we move to number E, you will be able to see that, okay, for number E we have 1, 2, 3, 4. We have 4 carbons there. Now you are going to check, okay, the longest carbon chain is 4, and we said 4 is but. 4 is but. Now, do we have a suffix? Do we have a branches? Yes. In carbon number 2, we have a branch, and in carbon number 3, we have a branch. And our branch, remember when it's 1 carbon, CH4, we said it's methane, isn't it? So CH4 is methane. So when it's CH3, it's no longer methane, it's now referred to as methyl. So you must know that this one will be methyl. So we have a methyl and another methyl in carbon number 2 and carbon number 3. So you will refer to this structure as 2,3 dimethyl. 2,3 dimethyl butane, because it's 4 carbons. And no, this is one name. You are writing one name. So you are saying in carbon number 2 we have a methyl, in carbon number 3 we have a methyl. Because there are 2 is di. If there are 3, it will be tri. So what is the longest carbon chain? Is butane. So you're able to get the name. Ethanoic acid, definitely we're going to ask you to draw ethanoic acid. You know it means two carbons. So you will move and say ethanoic acid. You will say, okay, this is ethanoic acid. You will draw 2 carbons. And then because it's an acid, it must have Cu at the end, which is C double bond O and an OH at the end of the name. And that is what we will refer to as ethanoic acid. I hope you got that, and then you are able to move. Now, this is what you must do first so that you understand the structure before you go to questions. These are the questions that were asked. Look at the first question there was define the term organic molecules. Remember what we were saying? We're saying organic molecules, these are molecules that contain carbon. They are made up of what? Of carbon. So we say molecules containing carbon atoms. So these are organic molecules. Write down the name of a homologous series of the following, of A. Remember the activity that we were doing. We said this is an alkene because of a carbon-carbon double bond. So you will simply say homologous series there is alkene. Remember we said there are 9 homologous series that we do. Write down the name of C, homologous series of C. C now, the homologous series, it was, okay, sorry, C, let me check something. Okay, yeah, I'm getting something here. That is the structure that we had. Yes, as I was analyzing with you here. Let me come back to say our C3H4. My bet is that we're having a carbon, triple bond, carbon, and another carbon. There are 3 of them, and 4 hydrogens. Yeah, that is the structure that we're having. That is the structure. So it's important that you always check what you are getting. So you have 3 carbons and 4 hydrogens, which is correct, which is what we do. It's an alkyne. This, sorry, let me put the hydrogens on this carbon. So you always count the number of bonds. You always count the number of bonds. That is for this one, C3H4. I'm saying what you will do is that we are having 3 carbons, but we have triple bond here, because then you have 1 here. Then because on this carbon there are 4 bonds, so you only need 3 here. So that is the correct way of drawing that structure. So that is, you got it correctly. So what is the homologous series? It's an alkyne. So this is an alkyne because there is a triple bond, not those diene that I have drawn there. Then you are able to get the structure correct like that. So it's important that as you do something, you go back, you check, you are able to see that. Now they are saying draw the structural formula of the compound represented by letters D. We've done it already. We've drawn the structural formula of pentane here. You're just doing that. You're collecting your 2 marks. You'll write the 5 carbons and you show all the bonds as you move with the structure like that. Now, write down the structural formula of compounds F. We've done that as well, where we said F is 2 carbons, and because it's a carboxylic acid is CO, C double bond O, and then OH, and then you are able to show all the hydrogens there. Then you got your 2 marks. Can you see that if you are well prepared, you are able to write and answer these questions? Write down the IUPAC name of compound E. So look at compound E there. We did that. Remember, we said you will first look at the suffix when you are naming. This is how you name. Let me take you through the process. You will look at the suffix. What will give you the suffix is the functional group. So you will say what is the functional group here, and then you move from suffix. You go for the longest carbon chain. So you're going to look for the longest carbon chain. Then you're going to look for the prefix. Let's go. Let's do it together. So what is the functional group? You can see that there is no functional group there. We're dealing with alkanes, so it's just a carbon hydrogen, a carbon single bond, and a carbon hydrogen single bonds. So you know that these are alkanes because there is no double or triple bond. So a suffix will be ane. Remember, for alkanes we write ane. And then you say the longest carbon chain. How many carbons? 1, 2, 3, 4. So you're able to say, okay, this is a but. 4 is a but. And then prefix, here we're saying branches, your chloro, your bromo, your methyl, your ethyl. So you're saying in carbon number 2, we have a methyl. In carbon number 3, we have a methyl. So that is 2,3. 2,3 dimethyl. So you see, you start from the end to the beginning. Now, when you write the name, you're going to say, you start from the prefix. You'll say 2,3 dimethyl, 2,3 dimethyl, 2,3 dimethyl butane, 2,3 dimethyl butane. So you're able to do that and you get all your marks. How do we mark this? We'll give 1 mark for butane. We'll give 1 mark for 2,3 dimethyl. You see, remember, between a number, 2 numbers, there is a comma. Between a number and a letter, there is a hyphen. So please don't forget that, because we do penalize you for that. So you're able to get your 2 marks there. Now, write down the alphabet name of E. That's what we're doing, question 2.4. Let's look at question 2.5. It says, for compound B, write down the name of the functional group. Now, you go to compound B, this one. I think we talked about this as I was explaining your strategy that side, to say for aldehydes, the functional group is the formyl group. Remember, for ketones, we said is the carbonyl group. For alcohols is the hydroxyl group. So you must know them. If you say write down the name of the functional group, you must be able to run to it and give it with no problem. Write down the molecular formula of B. Molecular formula, I told you, we are simply saying how many carbons do we have, how many hydrogens do we have. Now we are simply saying, okay, we have 1, 2, 3, 3 carbons. So you'll say it's a C3. How many hydrogens do we have? We have 1, 2, 3, 4, 5, 6. So C3H6 and 1 oxygen. So C3H6O. So you are able to do that, and then I hope you are enjoying your paper there, and you are able to see that this is doable, and then you just look at the structure and write molecular formula. So it's important that you know all the formulas, because if you can check, since we started, when we ask question, we are saying write down structural formula, write down functional group, write down molecular formula. So if you don't know the types of formulas, you're going to, even if you understand the question, but without you understanding the type of formula that you are supposed to write, you might have a problem. So I'm emphasizing that you must know. Now I want us to look at number A. I'm just consolidating naming, because we want you, for naming, you must know how to name organic molecules. Let's look at number A, for example. So remember, we said we start from the end, which is the suffix, the parent chain, and the prefix. So that's how we're going to name our structure. Now, if we look here in terms of the suffix, we are saying, do we have a what is the functional group here? Do you have a double bond? Do you have a triple bond? Do you have any other functional group? No functional group. I know you might think that bromo, there is bromo there, bromo must be a functional group, but remember the name, we call it haloalkane. Haloalkane. So we treat our halo, or our bromo, and our chloro, we treat them as substituents. So when you see a bromo there, you are seeing a substituent, you are not seeing a functional group, so that you are not confused. So when you look at the functional group, you see that this is an ane, because it's a haloalkane. The name will end with what? With an A, because halo is at the beginning. You see that, ne? So our suffix will be ane. For haloalkanes, the suffix is ane. The parent, we are saying the longest carbon chain. So we are going to count the number of carbons to say how many carbons do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you check all the options, but I think here the longest carbon chain, we have 6 carbons. So 6 is hex. So you're able to say hex. The prefix now is your bromo, your chloro, your methyl, your ethyl. So now let's look. On this carbon, there is a bromo. On this carbon, there is a methyl. I don't want to confuse you. I want you to understand me, so that any structure that comes, you are able to name. Now, all of this, we are saying they are all substituents. Take them as your children. You're saying, okay, I have 2 children, I must treat them equally, because they are all substituents. So they are all in carbon number 2. So I can't decide whether to start numbering from the right or from the left, because all of them, they are in carbon number 2. Is there any other thing that can help me with the decision? Let's go to carbon number 3. If you go to carbon number 3, from bromo, there is nothing in carbon number 3. But if you go to carbon number 3 from the left, there is another methyl. You see, When we start numbering, we're going to number closest to the mostly substituted side. So we're saying from the left, we have more substitutions. From the right, we only have bromo. So when we number, we're going to number where we have more substituents. I think you got me there. So this becomes carbon number 1, number 2, number 3, number 4, number 5, number 6. So don't forget that. So your numbering depends on the most if we don't have a functional group, if we don't have any other functional group, we have alkanes. You're going to look at the substituents to say, okay, do we have substituents? Yes. Now, if we didn't have the CH3, we're having CH3 here and bromo there, you would have said, okay, I will start numbering from the right, because bromo will get what we call alphabetic preference. But because in carbon number 3 we have another methyl, you will start numbering where you have more substitutions. So I hope you have understood that. Now, how are we going to name now? We're going to use, you remember, we must use alphabetical order to say 5-bromo. So we'll say 5-bromo. Our first substituent is 5-bromo. In carbon number 2 and carbon number 3, we have methyl. So it's 5-bromo, 2, 3 dimethyl. Then hexane. The parent is hex, suffix is ane. So you write it as one name, 5-bromo, 2, 3 dimethyl hexane. Then you know how to name the structure. So please practice so that you don't have problems. Now, if I was to use maybe number B here to emphasize on the naming again, so that you don't forget, we are saying here, look at the structure. You are going to do the same thing now. You do the numbering. Now, if you look, if I start numbering from this side, I say 1, 2. We don't have a substituent in carbon number 1. We don't have a substituent in carbon number 2. But when I start this side, there is a substituent in carbon number 2. So, number 3, number 4, 5, 6, 7. You see that, ne? Then, if we check, I'll say, okay, this one is the one that comes in carbon number 2. The first one to come is that one. Then you are able to use it in your naming. So it's very much important that you always look at that to say, okay, when do we first find our substituents? So we're finding our substituents in carbon number 1, 2, 3, 4. We're finding a substituents in carbon number 2 and carbon number 4. When you come from this side, you'll say 1, 2, 3. You're finding a substituent in carbon number 3 and number 4. But now you will start here because this one came first, the methyl on the left. So you will be able to say, okay, your structure is your chloro, 4-chloro. Remember, you put them in order. So you'll have 4-chloro, you'll have 2,5 dimethyl. You have it's just a question with 6, but you only do up to 6 carbons. So it's important that you always remember that you can't do more than 6 carbons. You do only 6 carbons. Now, we are saying isomers. So when you look at isomers, we have the 3 types of isomers that we do. This is the last part of this question 2 to say, remember, you have chain isomers, positional isomers, and functional isomers. Now, the chain isomers, we are saying these are compounds. You can refer to them as compounds or organic compounds. So these are compounds with the same molecular formula but different types of chains. So what is different is on the name. Iso means same. So you know that what is the same? Same molecular formula, different types of chain. Positional isomers, same molecular formula but different position because they are positional. So what is different is the what? Is the position. Position of the what? Of the substituents of the side chain or the functional group. I said SSF. You can have different position of the substituents of the side chain or the functional group as the examples are given there. The last one is the functional isomers. These are compounds or organic compounds with the same molecular formula but different functional. So what is different? You always look at the name. Different functional groups. And then we are saying functional isomers, we're saying cake. Don't forget, we're saying for carboxylic acid, the functional isomers are esters. For aldehydes, the functional isomers are ketone. So don't forget, when you see an aldehyde, you say what is the functional isomer, you will know that it must be ketone. When you say carboxylic acid, it must be an ester. Now we move to question 3, which is now physical properties. Now in technical science, as I indicated initially, that we do 4 physical properties, which is your melting point, your boiling point, your viscosity, and your vapor pressure. So those are the 4 physical properties that you are expected to do and to know and to be able to define. And then we're saying you must be able to discuss all of this in relationship to alkanes, alkenes, alkynes, all the 9 homologous series, and you must be able to compare these physical properties of different homologous series. Now, what is happening is that we're going to look at the 3 intermolecular forces that we focus on here, which is our London forces, our dipole, and our hydrogen bond. So those are the 3 intermolecular forces that we look at. Remember when I started, I said we are dealing with AAA, Hague, A, and C. Now don't forget, we're saying AAA, they have London forces. AAA, which is your hydrocarbons, your alkanes, alkenes, and alkynes. Your Hague, which is your haloalkanes, aldehyde, ketones, and esters, they have dipole. These ones have dipole. Your alcohols and carboxylic acid, they have hydrogen bonds. Now you must know that alcohols have one side of hydrogen bond. So alcohol can form 1 hydrogen bond, but a carboxylic acid can form 2 hydrogen bonds. So carboxylic acid are the strongest because they form 2 hydrogen bonds. So in terms of strength, we're saying London is the weakest intermolecular forces, followed by dipole, which are stronger. These ones, dipole, they're stronger than London. They are stronger than London force, but weaker than hydrogen bond. They are weaker than hydrogen bond. Don't write H bond, write hydrogen bond in full. Hydrogen bond, they are the strongest intermolecular forces. So we're going to look at questions where we'll use that. But the most important thing we're saying, remember guys, you must first know the definition. What is melting point? What is boiling point? What is vapor pressure? What is viscosity? Now, I will usually say melting point is not a point. It's a temperature at which the temperature at which the solid phase and the liquid phase are at equilibrium. The solid phase and the liquid phase are at equilibrium. Boiling point, we are saying boiling point is the temperature as well. It's not a point, it's a temperature at which the atmospheric pressure, the vapor pressure is equal to atmospheric pressure. So vapor pressure is equal to atmospheric pressure. I think you have somewhere where you're writing small notes so that you are able to remember this when you write your exams. And then our viscosity, we're saying, is the property of the fluid to oppose relative motion between 2 adjacent layers. And we're saying vapor pressure is the pressure exerted by vapor at equilibrium with its liquid. But for vapor pressure, you must say in a closed system. So you must be able to indicate that it is in a closed system. Now I talked about this to say AAA, your hydrocarbons, they have London forces. And then Hague, which is your haloalkanes, aldehyde, ketones, and esters, they have London forces and dipole. So they are stronger. Hence they are stronger because they have both London force and dipole. And you have your alcohols and carboxylic acid, which are having London forces, dipole, and hydrogen bond. However, when you refer to alcohols and carboxylic acid, we will most of the time refer to the hydrogen bonds because those are the strongest intermolecular force that you get. So don't forget, we are saying for alcohols, they can form 1 hydrogen bond. So they have 1 side of hydrogen bonds, and carboxylic acid, they have 2 sides of hydrogen bond. Now, as you are answering questions, we usually use the ICE method. The ICE, where here the I is the independent variable. What is changing in terms of the structure? So we look at the structure and then we compare. So you look at the structure here and then you compare the strength of intermolecular force. So there must be comparison. What are you comparing? The strength of intermolecular force and then the energy, E is for the energy. So we compare strength and energy. So we look at the structure to say what is different between these structures. And then after that, we say what is the strength of intermolecular force, how much energy will be required to overcome that intermolecular force. Now, without any wasting of time, let's go and do the activity still, question 3 from the same paper of May-June 2023. Now, we are saying the table below indicates the vapor pressure of 3 organic compounds. So we're given pentane, you know pentane, pent, 5 carbons. 2-methyl butane, you will see that but is 4, methyl is 1. So it's still 5 carbons, but there is 1 branch there. 2,2 dimethyl propane, so there are 2 branches. So you can see what is changing in the structure. What is changing, I said, is your independent variable. What is changing in the structure is that the number of branches are increasing. So you can see that the number of branch is what is changing in the structure. And then we're given the vapor pressure. What are we measuring? Your dependent variable. Remember, you must know your variables to say, okay, what we measure is the dependent variable. What is our dependent variable here? It is vapor pressure. So we're going to measure vapor pressure. What are we changing? We're changing the number of branches. So you are able to see that, okay, we have 0 branch, 1 branch, and 2 branches. So the number of branches, as the number of branches increases. So because we can ask you to explain the trends, to say, okay, as the number of branch increases, what happens to the vapor pressure? You can see as the number of branches increases, the vapor pressure increases. So you are able to see the what is happening there. Look at question 3.1. This is the question paper they wrote in June. They said define the term vapor pressure. Define the term vapor pressure. And then you are able to say is the pressure exerted by vapor. You see, I'm writing it in short so that you remember. PV, pressure exerted by vapor at equilibrium with its liquid in a closed system. Don't forget, it must be in a closed system. Which compound, 3.2, which compound, A or B, has the higher boiling point? So we're looking for the compound that has a higher boiling point between A and B. Remember, I indicated as we start to say melting point, boiling point, and viscosity, they increase with increase in the strength of intermolecular force. However, vapor pressure decreases with the increase in the strength. So you will see that the one that has the highest vapor pressure, it means it has the lowest strength of intermolecular forces. So you have to remember that to be able to say, okay, it means this is the strongest. It has the strongest. London forces, they are the strongest. And our London forces here, they are stronger than here on C, but weaker than on A. But on C is the weakest intermolecular forces that we get here. This is the weakest intermolecular force. So as the number of branch increases, the strength decreases. So you have to understand that the number of branch increases, the strength the number of branches increases, the strength decreases. Which compound, A or B, has a higher boiling point? So you will know that, okay, lower vapor pressure means higher boiling point. So you must know that the lowest boiling point, vapor pressure means the highest boiling point. So that will be compound number A. Explain the answer to question 3.2 referring to the structure. I told you the issue of the structure, the strength of intermolecular force, and the energy. So you can see that here you can refer to branch or you can refer to chain length to say, okay, A has as the longest carbon chain, as the longest chain. The chain is the longest in A, so we have longer chain in A. We have longer chain in A than B. So that is the structure. That is the first thing. You compare the structure to say, okay, A has more surface area than A has more surface area than B. So you will refer to it like that. And then you go to the next one. It says strength. Okay, so you're saying A has stronger intermolecular force. A has stronger intermolecular force than B. So that is the strength. You see, I'm writing in bullet form. I'm not writing a letter because you lose marks if you are writing one long thing where sometimes you lose the meaning of what you are saying. So it's important. You are saying, okay, I'm going to talk about A. A is less branched, or A has 0 branches. A has a longer carbon chain, longer structure, or longer chain, has a bigger chain length than B. And then you are saying, because of that, it has stronger intermolecular force, than B. A has stronger intermolecular force than B. If it's stronger, it means more energy will be required to overcome the intermolecular force. Remember, if you are saying the intermolecular force in A are stronger, it means you will need more energy to overcome those intermolecular forces. Then you must always collect that 3 marks. Please ensure that you always do that. So you will always look at the structure, what is different in the structures. You tell us what was different in the structure, and then from there you are able to move from there, and then we'll come after the break. Thank you very much. Welcome back. Now we're saying, what type of structural isomers are compound A, B, and C? So you can see they have different types of chains. So you will know that these are chain isomers. Already I've done 3.5 because I've explained what is different between them. So we are saying they are chain isomers because they have the same molecular formula but different. Most of the time when we say give reason, we're simply saying define that chain isomer, to say they have the same molecular formula but different types of chains. So you're able to get your 2 marks. That was the question 3 for the May-June paper, and I hope you got it. And then we're going to our reactions now, which is our question 4. Now remember the reactions that you do in technical science. You do addition, which is what we're going to look at now. You do substitution, and then you do oxidation, which is your combustion reactions. So we'll be looking at those reactions. Now for addition types of reaction, we are saying when you are having addition reactions, you must have a double bond or a triple bond. So you must have unsaturated, as I indicated, addition. Unsaturated hydrocarbons undergoes addition. So in our case here, let's not lose marks, let's collect the marks. When you see a double bond or an unsaturated hydrocarbon, you know that the arrows that comes from there are addition reactions. So the only reactions that we do for unsaturated hydrocarbons are addition reactions. So you see a double bond, you know that there must be addition. Now, we refer to that as addition reactions. However, there are types of addition. So we do the types of additions, which in this case is halo and high times 3. So we say halo and high times 3, meaning that the reactions that we do, the addition reactions, is halogenation, hydrogenation, hydration, and hydrohalogenation. So we do 4 addition reactions. Now if we add hydrogen, H2, we'll call it hydrogenation, and the H2 will be added on the double bond there. So one hydrogen will be added on the first carbon of the double bond, the other carbon on the next one. So it's easy to add hydrogens, and the reaction condition of the catalyst that we use there is platinum or palladium or nickel. So one of those 3 is the catalyst that we use. Now hydration, it means now we are adding water. Water, the structural formula of water, you must know how to write it. It's written like that. That is our water. The structural formula is written like that. Then when you add water, you know that, okay, you are having the H and the OH. Now, the issue here, which is very, very much important, is to say, when we add water, we're simply adding the H and the OH, because this water is made up of those H and OH. Now, the question is, where will the hydrogen go? Where will the OH go in terms of the structure? So you must look there to say hydrogen will go where there are many hydrogens. You see, look at this carbon number 1. It's richer. Of the richer becomes richer. So we're saying the carbon in carbon number 1, you will find that it has 2 hydrogens, and the hydrogen will go where there are many hydrogens. So the hydrogen will come here where there are many hydrogens. The OH will go where there are lesser number of hydrogens, and that we refer to as a major product. So for a major product, hydrogen goes where there are many hydrogens. I know you are writing somewhere so that you don't forget. Hydrogens will go where there are many hydrogens. OH will go where there are less number of hydrogens for us to get a structure. And immediately when you add, there is no more a double bond. So when you add water there will be no double bond. What you will have still have 4 carbons. Now with the H, remember the hydrogen came with the many hydrogens, there will be 3 now on the first carbon, and then you had this H here. The OH will come to this carbon, the OH will be here. Don't forget to show the bond between the O and the H as well. Remember, structural formula, we're saying you must show all the bonds. So don't forget that for structural formula, you show all the bonds. So you're able to do that structure. And you will say name the structure. Then you will say it's 4 carbons. So it's butan. Remember, in carbon number 2, you have an alcohol. So it's a butan to all. So you're able to name your structure as well. So it's important that you do that. And we're saying those are the catalysts. And the catalyst for adding water is sulfuric acid. Remember, where there is water, sulfuric acid likes to be there because it's a dehydrating agent. It's a nice catalyst for these reactions of water. So most of the time where water is being utilized, you must know that sulfuric acid will be our catalyst. Now, halogenation, we said we're only doing bromo and chloro. So if you are to add bromo, there are 2. So one will add on carbon number 1, one will add on carbon number 2. So it's as easy as adding of H2, because you don't have to choose where to go because you are adding 2 of the same. So it means now if you are to add 2 of them there on the double bond, you'll have a 1,2 dibromobutane as your structure. If you add Cl2, it will be 1,2 dichlorobutane as your structure. Now the last one is the hydrohalogenation, where you are adding the hydrogen and the halogen. The hydrogen and the halogen, which is HCl or HBr. We only do those 2. And you must know that if you are adding the H and the Cl, you will apply the same principles you used when you add water, where you said the hydrogen will go where there are many hydrogens, the chlorine will go where there are less number of hydrogen, meaning that will form 2-chlorobutane on that structure. I hope you have understood and you have understood it well. So our strategy here was saying USA, which means unsaturated becoming saturated, that is addition. So when you see a double bond becoming a single bond, you must know that we are having addition type of reaction. Don't forget, for this type of reaction of addition of HCl or HBr, we're saying no water must be present, because we'll always ask you to write the reaction conditions. So you must always remember what are the reaction conditions. Now, substitution, we're saying you are having here a saturated remaining saturated. The reaction is called substitution. So you have to know that for substitution, what is happening here is that we can have a butane and alkane. Then when you bring Br2, you won't add them. You are not adding, you are substituting. So you can't put all the Br2s. One Br will go into the structure, one Br will be replaced. So that's what we are doing now here. Now, what you have to understand here is that if you have a structure like that, is that the Br will substitute a hydrogen. Which hydrogen will be substituted? Let's look at that. Will it be carbon number 1 or carbon number 2? Now, when we substitute, we now saying the poor becomes poorer. So we'll substitute from the poorest carbon, the hydrogen from poorest carbon. So meaning we can only remove this hydrogen, these hydrogens, these ones, on the carbons, these hydrogens that are on the carbons that are more poor. You can see that these are 3 carbons, so you can't substitute there. For you to get a major product, you will substitute one of these hydrogens. So you can remove this hydrogen and put a Br there, and then you will form HBr. So you are able to substitute there. I hope you got that. And then it means that we have 2 reactants, which was our butane and Br2. They are forming now a halo alkane and an HBr, which is a inorganic molecule. HBr is formed, and a 2-bromo butane was formed there. From there, we can use water and mild heat, or dilute sodium hydroxide and mild heat. That is, the process is called hydrolysis. So there are 2 types of hydrolysis reactions that you must remember. So those hydrolysis reactions are as indicated there. So I hope you will be able to remember that, okay, if you have a halo alkane, you can use water and mild heat, or you can use dilute sodium hydroxide and mild heat. Then you are able to form your alcohol, which in this case you will have your alcohol there. Don't forget to show all the bonds between the hydrogens and the oxygen there, so that all the bonds, so it's a nice structural formula that is formed. So you must know that you have 2 types of hydrolysis. The other one you use water and mild heat, the other one you use dilute sodium hydroxide and mild heat, but all of them, they form an alcohol, and we refer to them as hydrolysis. You can bring back the HBr there, then it's still halogenation. So it means if you put the HBr, it will remove the OH, then where there is OH, there will be Br. So the reaction can be done like that. So we have only four substitution reactions that we do in grade 12. So you will remember those as we move. Now look at question 4 for this paper that we have been busy doing. We're saying write down the type of addition reaction represented by reaction 1. So as I indicated already, that when you see a double bond, you see addition reaction. So when you say what type of reaction is reaction 1, you know it's addition. Why is addition? Reaction 2 is addition. Why is addition? Because it's unsaturated. It's forming saturated, because propane is saturated. Double bond is forming single bonds. We call that addition reaction. So you're able to see that. But now, when you look at this one, we're having a saturated compound forming a saturated compound. So you're going to say triple S. Saturated forming saturated, that is substitution. I hope that helps you. You will always be able to remember what type of reaction. So our question is saying, what type of reaction is reaction 1? We know already, they said type of addition. So they told you that it's an addition. So they didn't say what type of reaction. They say what type of addition. Remember what I said? I said we have 4 additions, which is halogenation, hydrogenation, hydration, and hydrohalogenation. So on this one, you're able to check to say, okay, what did we add here? What do we have now? We have a bromo. Bromo doesn't go alone. So it's a hydrohalogenation. We add a hydrohalogenation here. We have added, because if you add Br2, it will add all of them. It will be a dibromo. So this one is, you have added only one bromo, so which means we have added HBr. So you're able to say, okay, this is a hydrohalogenation. Say, will I be wrong if I say hydrobromination? No, you are still correct. We'll still give you your mark for saying it's hydrobromination. So the type of addition is hydrobromination, or hydrohalogenation. Correct, you are getting your mark. On this one, you can see that now we didn't have hydrogens there, but now it's propane. The double bond is no longer there, it's propane. It means we have added the hydrogens there, which is hydrogenation, because we're adding hydrogens. Hydrogenation. I told you that for this reaction, our catalyst is platinum, palladium, or nickel. Don't forget, please, as you go to the exam. Now, HBr as well, as you do reaction 1 there, the addition type of reaction, we are saying now no water must be present. I think we talked about that, to say no water must be present, because if there is water, water will want to add itself there. Let's move now. Use structural formula to write a balanced chemical equation for reaction 3. So reaction 3, they are saying you are having a 2-bromo propane. In carbon number 2, you have a bromo, and the structure is propane. I know you know how to draw it. You must be able to look for this question paper over the weekend. Do it again on your own. So you have 2-bromo propane, Definitely, we said we can use dilute sodium hydroxide. I told you that you can use dilute sodium hydroxide, or you can use water and mild heat. I we said and mild heat. Sometimes we just say heat. It's fine. Heat is heat. Now mild heat. Now we can use any of those. So remember, we said we have two types of hydrolysis. You can use that or that. And then what happens is that we are going to form what? Now we're going to have the same structure. Now where there was bromine, there will be OH now, because it's a substitution. OH is coming to substitute the bromine there. Then you have that, you have that plus, so sodium will be together with bromine, it will be plus sodium bromide. If you use water, you will get the same structure, because you are going to take the OH will go where there is bromine, the H and the Br becomes together, they will form HBr plus that structure. So you can use any of those reagents, you still be able to do that. Now the trick in terms of this question is that they said use structural formula. So if, for example, structural formula, if you write water like this, it's not a structural formula, you'll lose the mark. You must write your water as a structural formula like that. You get what I'm saying? Because we're saying when you say structural formula, you show all the bonds, you show all the bonds that are involved. So it's very much important that you show those bonds, and it's a structural formula. Even for your products, you show all the bonds, and then you are able to get all your marks. 4 marks is a good marks. Write down 2 conditions for reaction 1. Reaction 1 is that one. So I think we talked about it to say, okay, there must be no water, no water present in terms of that reaction. So I hope you will be able to do that question and move forward. Now they said a blue flamed gas used to cut and weld metals in the welding industry. So there is an industry where they deal with welding, reacts with excess oxygen. So you know that you are given C2H6 is reacting with oxygen. So that will be your combustion reaction. So combustion reaction, you know, it forms 3 things. It forms carbon dioxide, it forms water plus NH. But in terms of balancing, we are focusing on carbon dioxide and water. So please, learners, when we are marking this type of questions, we always for this 3 mark, 1 mark is for reactants, 1 mark for the products, and 1 mark for balancing. So please don't lose the marks. If you have to get, you will get already you have 2/3 for writing that combustion is. You write the molecular formula that you are given, the C2H2, you write the oxygen, excess oxygen, you write carbon dioxide and water. Already you have 2/3. So the other mark will be for balancing the equation, where you will say, okay, how many carbons do we have? We have 2 carbons here. If you were to write 2 there, the carbons will be balanced. Then you go and balance your hydrogens, and you go and balance your oxygens as well. As you can see that you had C2, you had 2 of those, and then you had 6 of that, and then you were having H2O there. So if you are to check, let me say, that will give us 2 carbons and carbon, they are balanced. Then you go and balance your hydrogens. How many hydrogens you had? 3. If I put 3 there, you'll have 6. You'll have 6 hydrogens on the product and 6 there. But now we have the oxygens that are the ones that are not balanced. In this case, you have 2 times 2, that is 4. In fact, we had 5, so I should have just put 5 here, 2,5 here, 2,5. Then that gives you 2 balanced. And then we had 2,5 times 2 is 5, it's balanced. And then to balance the reaction, you have to multiply everything by 2. So that will have given you 2C2H6 plus 5O2, giving you we said times 2, so it's 4 carbon dioxide plus how many waters do you have there? You had 12, which is 6H2O. Let me check that. Let me check how many do we have now. We have 4. The hydrogens, we have 12. They are balanced. the carbon, the oxygens. So it's 2C2H6 plus 5O2. Then we are able to get to balance that equation to say that one plus that one. Then you check all your reactants to say are they balanced, all of them. Then you are able to balance the equation. Most of the time I just use a simple thing to say, okay, if we have CnH2n, because when you are having C2H2, that was my bad, C2H2, not C2H6, hence I was wondering. Then plus oxygen forming carbon dioxide plus water. So always make sure that you are writing the right molecules that you are given. So when you are given like that, as I indicated, you go for it for balancing, and then you are able to say, okay, we're going to have 4 carbon dioxide, 2,5. We said 2,5 here. We said 2 is 4. So we have 4 carbons. Balanced, we have 4 hydrogens, and then 4 hydrogens, but we have a 2,5. You multiply by 2, you get your 4C2H2 plus 5O2, giving us then that will give us 8, and put it this way, CnH2n plus 2. That is our organic molecule that we are given, and then we are able to check it. So we are saying we are going to balance C2H2 plus oxygen forms carbon dioxide plus water. So that is our molecule that we are moving with. So we are saying we have 2 carbons, so the carbons are balanced. Now you must be able to move to hydrogens to say how many hydrogens do we have. It was C2H2. We have 2 here, they are balanced. Let's go to oxygens. How many oxygens? We have 2 here. How many this side? We have 2 times 2, which is 4, plus 1, we have 5. So 5, to get 5 here, you will put 5 over 2 here. So you multiply the whole expression by 2, so you'll get 2C2H2 plus 5O2 gives us 4 carbon dioxide plus 2 waters. So if we check, you have 4 balanced hydrogens. You have 2 times 2 is 4. You have hydrogens here, 2 times 2 is 4. Oxygens, you have 10. You have 4 times 2 plus 2 is balanced. That is the thing. So you see all that working just for that 1 mark. So you will see that it's important that you practice it. But now we are saying you must be able to get all the mark. So you are able to get your next mark. And then as we move, write down the name of the reaction. We said it's oxidation. So we accept combustion reaction. Write down the molecular formula to write down a balanced equation is what we have done there. You said that structure, then you get 3 marks. But the most important thing, we're saying 1 mark for the reactants, 1 mark for the product, and 1 mark for balancing the reactions. Then you are able to do that question, and then we are able to move with no problem. Now, with time, I will try and move faster to say still we have to look at the questions that talks to semiconductors. To say we can, in 2021 we had a question that says name the process that is used to improve conductivity of semiconductors, which is the doping process. You must be able to define what is intrinsic semiconductor. We're saying is a pure semiconductor. You must be able to distinguish between the N-type semiconductor and the P-type semiconductor. So we're saying an N-type semiconductor is a semiconductor with excess electrons. So it has more electrons, negative charges carriers. It is formed when an intrinsic semiconductor is doped with pentavalent impurity. So remember, when you introduce the impurity, you are giving more electrons. Hence, we are saying N-type because electrons are negatively charged. A P-type semiconductor, we are saying these ones, they have a positive hole, meaning that they are 1 electron deficient, and it is formed when intrinsic semiconductor is doped with a trivalent impurity. So that is the one that we are referring to there. Now, our last section, which is the redox reactions, is that the pre-knowledge, you have done this in grade 11. you have done what is oxidation. You have done that oxidation is loss of electron, reduction is gaining of electrons. So don't forget, loss of electron is oxidation, gaining of electrons is reduction. And we are saying loss of electron is oxidation, that gives us a reducing agent. And the gaining of electrons is reduction, that gives us the oxidizing agent. The reducing agent we are saying is oxidized, and the oxidizing agent is reduced. So always remember that we have loss of electron, which is oxidation, and that gives us the reducing agent, which is oxidized. We have gaining of electrons, which is reduction, oxidizing agent, that is reduced. So in that way, you are able as well to define what is a reducing agent, because when you say what is a reducing agent, you are simply saying it's a substance. A reducing agent is a substance that undergoes oxidation. What is the oxidizing agent? It's a substance that undergoes reduction. So don't forget that. We have an anode. We're saying this is anode is an electrode. It's an electrode where oxidation occurs, or where oxidation takes place. Cathode is an electrode. You are taking it from the ode there. The ode there is telling you that this is an electrode where reduction takes place, or reduction occurs. Hence we are saying an ox, and we are saying red cat. Don't forget, an ox, we are saying at the anode, that is the electrode where oxidation takes place. At the cathode, that is the electrode where reduction takes place. Now, the issue of oxidation numbers as well, you have done in grade 11, and electrolysis, which in this case you have done electrolysis of copper chloride. Remember, in grade for question 5, we only do electrolysis of copper chloride and electroplating. So there are only two processes that you are expecting in terms of question 5. It's either you will get electrolysis of copper chloride or electroplating. So if you have two processes, you know those are the only two processes that we do for question 5 or for topic of electrolysis. So please don't forget that. And we are saying electrolysis is a what? It converts electrical energy to chemical energy. So don't forget, it's from electrical energy to chemical energy. I know you've been writing paper 1. You don't confuse chemical with mechanical energy. So you can't say from electrical to chemical energy to mechanical energy. No, is in paper 2 is from electrical to chemical energy. And this process, we call it non-spontaneous because we use a DC source to be able for the reaction to be able to take place. So it means this reaction cannot take place if we didn't have the DC source there. You need the DC source. We need a source of current so that the reaction can take place. And we call it endothermic, which means energy is being absorbed in this reaction. So we are saying 3 most important definitions for this question are the following. Number 1, what is electrolytic cell? If you would say what is electrolytic cell, you'll say it's a cell that converts electrical energy to chemical energy. You must know that it's non-spontaneous, and you must know that it is endothermic. And the other definition, which is important, is what is electrolysis. You see the difference now. What is electrochemical cell? What is electrolysis? If we say electrolysis, we're talking about the process. If we say electrolytic cell, electrolytic cell, we are referring to the cell. It's a cell that converts electrical energy to chemical energy. But electrolysis is the process that converts electrical energy. So when you say electrolysis, now you say it's a process, but it still converts electrical energy to chemical energy. The most important thing, don't forget the energy conventions in terms of that. Now, in the paper, they give the learners these tools. They say these are the apparatus and solution to assemble electrochemical cells. Now, you will understand that, okay, we have one beaker. So in one beaker, we have 2 electrodes. All of them are carbon. Now, remember this as I conclude the lesson, to say, always remember that when you are given the carbon rods, only the 2 carbon rods, you will know that that is electrolysis. It can be, it's not electroplating, it's electrolysis. And the only electrolysis that we do is electrolysis of copper chloride. So you got to know that as far as you are doing technical science, we have 2 carbon rods. It must be electrolysis of copper chloride. And then we are saying don't panic. We use the word panic here to show that positive, which is the longer line there, it is positive. The shorter one is negative. Positive is anode. Positive is anode, which means this side you'll have your anode, and the negative is cathode. So you have to know, already we said electrons will always move from anode to cathode. So don't forget those small things that we just talked about. It's okay, you are having the anode and then you are having the cathode. So you must be able to understand that this is the type of reaction that is going to take place. And the other thing which is important that you must always remember is that here on the electrolysis of copper chloride, you must know that it is the chlorine that is going to lose the remember, usually copper as a metal, it will like to lose electrons, but in this case it is copper 2+ that is gaining the electrons to form copper, while the 2Cl- is losing electrons to form Cl2. So you will see that around the anode here there will be bubbles. Why bubbles? Because there is a formation of the chlorine gas, and around the cathode there will be copper, there will be brown deposits here that are being formed around the carbon rods. So these carbon rods, you will see brown pigment. This other one, you will see bubbles because the chlorine gas is being formed. So you got to know the reaction that takes place at the anode. It will always be the chlorine that is losing the electrons to form Cl2 gas. Cl2 gas is being formed, and you have the copper 2+ that is gaining the electrons to form copper, and we'll have a formation of a brown pigment, and we'll have that. So already you have used the conducting wires, which are these wires. You have used the cell, this is your cell. You have used the copper chloride, which is your solution there, and then everything has been utilized. So you must be able to assemble your cell and to know that chlorine will lose electrons, then copper 2+ will gain those electrons. So in real sense is that on the cathode side, you will see that the carbon is going to gain, because there is gaining of electrons, it will increase in mass. But on the anode, you will see the bubbles because the chlorine gas is being formed. Let's look at the question at the question that they were given there to say what type of electrochemical cells can be assembled using all of the apparatus above and the solution. So already you said it's electrolytic cell. Write down 2 components in the list that justify the above. Remember, electrolytic cell, we use one beaker, we're using a battery, we're using 2 carbon rods. So those 3 things tells you that here we are dealing with the electrolytic cell. Now, in assembling the electrochemical cell, one electrode was connected to the positive terminal and the other electrode to the negative terminal of the cell. Now, we know that one will be positive, one will be negative, as I've shown you in the previous page. Which one of the electrodes will be the anode? Write down only electrode connected to the positive. Remember, anode is connected to the positive terminal. I said panic. So the panic there is reminding you that positive is anode. So the anode is the one that is connected to the positive terminal, while the cathode is connected to the negative. So the one to the anode is the positive terminal, which is this one. Write down the half reaction takes place at the cathode. So at the cathode, we're saying you have copper 2+ that is gaining electrons to form copper. Write down the name or formula of the product formed at the anode. We said it should say at the anode, 2Cl- is going to lose electrons to form chlorine gas. So you'll have chlorine gas that is formed. So they say write down the name or formula of the product formed. So not the whole reaction, but the product, which is Cl2 gas. So Cl2 gas is formed. You can say chlorine gas. You can say write the formula. They said name or formula. Write down 3 different examples of alternate energies that you can use, so you can be able to talk to a biodiesel and all those the forms that we your solar that you are using this time when we don't have electricity. And it's very much important that you understand all these processes. And the last cell that was supposed to know is electroplating under this topic. Under electroplating, I can see that time's not on our side, but I'm trying to cover, because we are saying when you have 2 electrodes that are the same, like we had carbon and carbon in the previous question, we said that was electroplating. That was electrolysis of copper chloride, because it was a carbon and a carbon. But in this case, you can see we're having silver, which is the metal, and an object. Immediately when you have a silver, an object, or you have two different metals, for example, you will know that in this case, your electrodes are different. In this case, it's carbon and carbon. You know it's electrolysis. But now, if you have a case where you are having, in this case, you are having a metal and an object, then you will be able to know that, okay, this must be electroplating. So when there are two different electrodes there, you know that, no, this must be electroplating. And during electroplating, we're saying the metal, in this case, is silver. Silver will lose electrons. The metal loses electrons. And then on the cathode, where we have the object, where you find the object, we're saying you just write the reverse reaction of that. So you'll say Ag plus an electron forming Ag. And then when we come back, we're concluding the lesson. We'll just take this 1 minute break. Then when we come back, drink water, then we are able to finish. Thank you very much. So we are saying electroplating is another process. So I've told you the difference now, that the main difference to look at, if we are having a carbon and a carbon, or two of the same electrodes that we are using there, in terms of these processes that we do in technical science, is that will be electroplating. But immediately when you see we have two different electrodes, you must know that is electroplating. When they are the same, like carbon and carbon, or any platinum and platinum, you will know that is electrolysis of copper chloride. So because we only do electrolysis of copper chloride and electroplating. So we are saying for electroplating, we'll have two different, in this case, we have a metal and an object. Then you know that when they are different, that must be electroplating. I hope you will be able to understand that, and then it will help us as well as we move with it with no problem. Then you are able to remember at all times what we are dealing with. Now, with no wasting of time, we'll look at the galvanic cell, which is our last topic. Electrochemical cell, this one, it converts chemical to electrical. It's no longer electrical to chemical. And this one we're saying is a spontaneous reaction. It is exothermic. And the common apparatus, we no longer have one beaker. We're saying now we're using two beakers now, as far as we're dealing with this one. And in these two beakers, we're going to have our metals that are immersed inside, and we're going to have a salt bridge that joins them. So you are able to see that we have a salt bridge that completes the circuit. Then you are able to see that this now is a galvanic cell. So you got to know that they are immersed in a solution, and that solution that conducts electricity, we call it an electrolyte. So without any wasting of time, we're going to move to the question that is based on this section, which was question 6 in terms of the paper that was written in May, June. So we're saying learners performed an experiment to determine the electrode potential of an electrochemical cell under standard conditions. So we're saying the conditions were standard. So you must know what are standard conditions. Remember, when you say standard condition, we're saying initial concentration is 1 mole per cubic decimeter, and then we are saying temperature is 25 degrees Celsius, and we are saying pressure is 1 atm or 101.3 kilopascals. So when we ask, say, write down two standard conditions, for example, you will write those first two, because this one applies to gases. So if you have gases, you can include it, but if no gases, the standard conditions will be those two. So if you find a question that needs you to write down the standard condition, you'll say initial concentration of 1 mole per cubic decimeter, temperature of 25 degrees Celsius. Now you will see that as we are having here, we are having our magnesium this side, and you are having our zinc that side. So it's a magnesium zinc cell. So what is most important here for you to understand is where will the electrons move. Remember, when you look at table 4b, you will see that magnesium, it comes first. You have magnesium 2 plus 2 electrons, giving us magnesium. That's how it's written on the table. And then you have zinc 2 plus 2 electrons, giving us zinc. But now magnesium is minus 2,36, while zinc is negative 0,76. This is very much important, my learners. Remember, the one that will lose electrons is the one that is more negative. The more negative one is the one that will lose electrons. So in this case, you are having magnesium 2 plus 2 electrons, magnesium, we are saying is negative 2,36. You are having zinc 2 plus 2 electrons, forming zinc, and we are saying is negative 0,76. So what happens is that we are saying you're going to use the Z method. You can just write Z there to say the first one, it will reverse all the time. Here we're using table 4b. When we are dealing with question 6, we use table 4b so that we don't have confusions. So I'm saying you just go to the table, you look for magnesium and zinc, you get all of them, then you are able to write them to say, okay, which comes first? Minus 2,36 minus 2. Then you write your Z. Your Z is showing you that the first reaction will be reversed. So you always reverse the smallest standard reduction potential. So magnesium, you will say magnesium 1 arrow, you write magnesium 2 plus 2 electrons. Then for zinc, you copy it as is, zinc 2 plus 2 electrons, forming zinc. Don't forget that in your book, we don't want you to indicate the 2 arrows because they will confuse you. Just show us the 1 arrows for the half fraction to say the magnesium will go backward. You will start it from magnesium to form that. And because the electrons are on the right there, we are saying this is loss of electron, which is we refer to as oxidation, which is where you find your reducing agent, which is oxidized. Here you are having your gaining of electrons, which is your reduction, which is your oxidizing agent is reduced. So you are able to see that, to say, okay, magnesium is losing electrons. It means it's undergoing oxidation. So we refer to it as a reducing agent. So we're referring to it as a reducing agent, and our reducing agent is oxidized. Oxidized means increased. You can see magnesium comes from 0. Now it became from 0 it became a 2 plus. So you are able to see that from 0 it became a 2 plus, and then we're having a zinc 2 plus that became zinc there. So you're able to see that we don't have no problem. We are moving. There's no stress. Now let's go to questions without wasting of any time, and then so that we're able to finish what this question, which is our last question. It says state the energy conversion taking place in the cell. Remember, energy conversion here we said is from chemical energy to electrical energy. You must write it in full. Write down a balanced net ionic reaction of the cell. A balanced net ionic. Net means you are adding them together. Remember what I indicated in the previous page, that magnesium is losing electrons and zinc 2 plus is gaining electrons to form zinc. So what you do, you cancel the equal the balanced electrons. The electrons must be balanced, then you cancel them. What is on the left, you write on the left, like magnesium plus zinc 2 plus forming magnesium 2 plus zinc. So you are able to write the cell like that. Then that is your 2 marks that you got from there. Now in 6.1.3 it says, in which direction will the SO4, which is the N ion, the N ion, remember you said oxidation takes place at the anode and reduction takes place at the cathode. So don't forget that where reduction takes place is the cathode. So N ions, they will always go to the anode, and our anode is where magnesium is. So you will know that here on the salt bridge, the SO4 minus 2 minus will move towards the anode. They will move towards the anode. And don't claim that the anode is always on the left, because most of the examples we do, the anode is on the left, and on this one, you see that our anode is on the right-hand side. So we can bring it like that, and then it must not cause confusion to yourself. So you know that it means that the SO4 minus will go that side, and then in which direction will it go? We said that is the reaction spontaneous or non-spontaneous? Remember, we said galvanic cell is spontaneous, but electrolytic cell is non-spontaneous. So this one you will say is a spontaneous cell. And then we are saying, is the cell reaction spontaneous or non-spontaneous? We said it's spontaneous. Calculate the EMF. Please copy the formula straight from the data sheet, please, so that we don't have problem. It says E cathode. Don't shorten it. Just copy it the way it appears. Then you are able to get the 1 mark. But if you change anything there, we won't give you the mark for writing the formula. And then we were able to say that was the cathode was zinc, which is negative 0.76 minus 2, we said this 2.3. We said it's 2.36 minus 2.36, and then we're able to do the math. So we're just combining that, and if the calculator works well, you will be able to get positive 1.60. Hence, we're saying spontaneous, because when it's spontaneous, it means that your answer must be positive. Your EMF must be positive. E of a cell must be positive. So it shows that this was indeed a spontaneous reaction. They say now in 6.2, component A is removed. So they are removing component A. You can see this one is a salt bridge. Write down the name of component A. We're saying it's a salt bridge. They are removing the salt bridge now. What will happen? Will the light bulb glow? Just say yes or no. So you have to just answer the question. You will say no. It will not. It won't be able to glow. Why it won't be able to glow? Because the function of the salt bridge is to complete the circuit. So the circuit will be incomplete without the salt bridge, and then it will as well be unable to maintain electrical neutrality. So that is the main thing to say. You explain the reason why it won't glow. It won't glow because of that reason. So it's very much important as well to remember that the anode, the one that loses electron, it must decrease in mass. The cathode, the one that gains electrons, it must increase in mass. So you must be able to know that the anode decreases in mass no matter which two substances you are given. You must know that the anode will decrease in mass, the cathode will increase. And as the anode, the side where the anode is decreasing in mass, you must know that its solution, which in this case is Mg2 plus solution, it will increase. The solution will increase, the electrolyte, concentration of the electrolyte will increase. On this side, because it's busy gaining electrons and it's increasing in mass, the solution will decrease. So I would like to say these are the things that you must take care of and remember all the time as you prepare for your paper. The main thing, your organic chemistry, you have seen how many marks that you are going to get from organic. I hope you will spend much time doing that. In question 5, we are saying we have only two cells that we are doing is electroplating and electrolysis of copper chloride. And we are saying that as far as you are dealing with those, ensure that you are able to differentiate between them. We're saying when you see a carbon and carbon, you know that this is what we are dealing with. We're doing electrolysis of copper chloride. But if you have two different electrodes there, you will know that that must be electroplating. And for electroplating, we're saying the reaction that takes place on the anode is the reverse of that reaction takes place at the cathode. You have seen when Ag forms Ag plus an electron, on the cathode side, Ag plus will gain electrons and form Ag. On this one, we are saying you go to the table of standard reduction potential, you copy, you look for the two substances that were given. In this case, we were given magnesium and zinc. Magnesium came first in terms of the table, then that's when magnesium lost electrons, and then zinc that came after, it gained the electrons, and you only write one arrow, you don't write two arrows. I hope this will help you as you revise and prepare yourself for your coming exams. I wish you all the best. Thank you for watching this lesson. See you next time. Goodbye.